Welcome to Lambton College's Operating Engineering Studies Lab. Today we're going to do Experiment 10, Pressure Gauge Calibration. Beside me there are several types of pressure gauges. This one is oil-filled, if there's corrosive materials beside it. They come in different scales, meaning they could be in pounds per square inch. If there's no units written on the gauge, you can assume that it's pounds per square inch. The pressure comes in the bottom, and inside pressure gauges, you have a flat piece of metal called a bourdon tube. As the pressure rises, the bourdon tube tends to straighten out, and it's mechanically linked to a pointer on this side. And if for some reason the pressure gauge gets out of calibration, we can calibrate it. That this ring unscrews, the glass comes off, and you can use a screwdriver to reposition the needle. Beside me we have our calibration tester. We have a piston that we're going to put weights on, and the first step in the procedure is to put the equivalent of 40 pounds per square inch of weights on here. These weights don't weigh 40 pounds, but due to the surface area of the piston, it's the equivalent. And we've got a water-filled cylinder, and Mike is going to pull out the front valve, and he's going to close the rear valve tightly, and he's going to check that the valve to the pressure gauge is open, and he's going to start pumping, and we should see the pressure start to rise on our gauge, and at the same time the weights will rise, and when the weights are spinning freely, somewhere near we have a black mark under the weights. When the bottom of the weights are near where that mark is and spin freely, we will record what the pressure gauge reading is. The piston assembly itself is the equivalent of 5 pounds per square inch. So we've got 40 pounds of weights. So they're spinning, and the important thing is that it's not touching the bottom or the top. If it is, we can release a little bit of pressure. But this seems fine, so pressure gauges sometimes stick, so it's okay to tap the gauge with your hand, not your wrench, on the side and not on the glass. So Mike is going to read the gauge, and we have best luck closing one eye and getting your nose over the center of the pointer, and we're going to record the pressure, which is 46 psig, and we were expecting 45, so you need to do the calculations for what percentage error is that gauge off at that point. And next we're going to go and add more weights, and normally pressure gauges are most accurate in the top third of their range. So what's important is what it's reading in the middle. And the range of this gauge is 0 to 300 pounds per square inch in units of 50. So if you were asked to provide new gauges for a system, then you would like to get a gauge whose range is roughly double of what the normal operating pressure of that system is. So we recorded our weights. So I'm going to take the two WG25s off, which were the equivalent of 40 psig, and grab a WG26, which is the equivalent of 100 pounds per square inch. Move that out of the way, right? And Mike is going to continue to pump the handle, and hopefully we're going to get the equivalent of 100 pounds on our gauge. 27, 225.
103.
Okay, so Mike has observed that we have 103 PSIG on our gauge, and it should be 90. This is 95 plus the 5, so it's 100 pounds versus 103, so we have a 3% error at this point. So now that we've got 100 pounds on here, our next objective is to put 200 pounds worth of weights. In order to do that, I need to add a WG27. So we have 201 pounds at 200. And the next weight that we need to reach per our procedure next in our procedure, we need to reach 240 pounds, so I will add our two small weights. And we'll see what we get. So Mike is observing 239 pounds with 240 pounds of weights. Lastly, we need to put the equivalent of 300 pounds of weights on. So I'm going to remove the two, move our 40 pounds, and I'm going to add one more 27. Hopefully we get 300 pounds. So our gauge is pretty good. We've got 300 at 300. So this concludes the experiments. We will depressure the cylinder by opening the front valve and removing the weights.